Hi everyone, welcome back. Today we are going to see about the construction and working of three-phase induction motor. So in DC motor it has the stator and rotor. So it is just to remember the red is indicated north polarity and south is indicated as south polarity. Okay, and here when the rotor it aligns with the stator and and after that the commutation contacts are changed so that it will be continuously rotating. So in AC machine also it has two types, one is called stator and another one is rotor. So the stator it consists of three windings and all the windings are displaced by 120-degree phase shift. So there are two types of rotors are there. One is called scroll gauge induction motor, another one is slip ring induction motor. So here the laminated cylindrical core with the parallel slot of the outer periphery. Here there will be rotor bars are used. The two rotor bars are connected with the two end rings, and the end rings are short circuited. And it is very robust construction, low starting torque, and it is not possible to add any external resistance in order to control the speed. And the wound rotor or is nothing but slip ring induction motor. So here also it is similar to that one, but here the external resistance can be added, because here we are added the slip rings. Three slip rings are added in the shaft, so which is in the rotor side. So here for the squirrel gauge induction motor, the supply is given only to the stator winding, and for the wound rotor induction motor the supply is given both the stator as well as rotor. So in squirrel gauge induction motor the speed control is not possible, and for the squirrel gauge induction motor the speed control is possible with the help of slip ring, because here the variable rheostat is connected across the slip ring. So by adjusting the resistance we can able to control the current which is flowing through the rotors. Okay, so this is the principle of operation. This is nothing but a rotating magnetic field. So here the supply is given to the stator winding. So the stator it consists of three phase supply. So here the R phase, Y phase, B phase will be there. So R is energized, so it produces flux. Next Y is energized, it produces flux. The next B is energized, it produces flux. So that so simultaneously all the phases are 120-degree phase shifted. So all the phase with a certain time interval, all the phases will be synchronized and it will be energized at a particular interval of duration. So at the time of energization the flux will be produced at that particular coil. So while you can look into the diagram, so the flux will be just like rotating. So it is nothing but a rotating magnetic field. Okay, so this is nothing but an R phase, Y phase and B phase. So there are the three phases are there. Okay, so in general the speed is calculated based on the formula synchronous speed is equal to 120 F by P, and the number of poles is nothing but with respect to the number of poles and with respect to the frequency. Okay, so here, so this is a three-phase current. When the A current is maximum, the A coil. Okay, so the magnetic flux density is perpendicular to the A coil, and if the B flux is maximum and the produced flux and the producer flux is perpendicular to the Y phase, and the B phase and the C phase is maximum, the producer flux is perpendicular to the C phase. Okay, so all the 120-degree phase shifted. So this is a rotating magnetic field. When A is energized, the rotor is aligned with A, and B phase is energized, B and rotor is aligned with B, and C phase is aligned, it will align with C. So it will be just like, and the rotor slip. So here the slip is calculated based on the formula of the synchronous speed minus the actual speed of the rotor divided by n synchronous speed. Okay, so it is nothing but in wastage power. But here the synchronous speed and the actual speed will not be same, because it consists of some amount of losses will be presented. Okay, so what will happen if rotor reaches the speed of stator flux? So no relative speed between the stator field and rotor conductor, and no induced current, and no torque in the no torque. It is practically possible. No, it is practically not possible because friction will slow down the rotor. Okay, so this is the formula for synchronous speed, ns minus actual speed divided by ns. And this is the comparison of DC motor, brushless DC motor, brushless AC motor, and AC induction motor. Okay. So this is an assessment. If the rotor speed reaches 1500 rpm means what will happen to the motor? So just to put your answer in the comment section, and these are the few references. Thank you.